All right, well, good morning, everyone. Welcome to another Research Computing and Data seminar. Um, Happy to see everyone here today. So yeah, as you know, today the topic is going to be object-oriented programming, which if you've done any coding, I'm sure you've encountered before. And you may have heard the term or you may have not, but um, it's a object-oriented programming is like, pervasive throughout like coding and coding languages. So even if you haven't heard of it or not really quite sure what it means, chances are you've definitely used it in your work. So I thought today what we do before jumping into questions is I was kind of do like a review of the article, kind of go over the main three concepts of object-oriented programming, kind of go over those and then kind of go over the general concepts, and then maybe we can jump into some of those questions and have a broader discussion about it and how to use it in our own work. So I'm going to share my screen just so we have the article up there in case. I'm not going to read from the article, but I think it'll be a good reference. Yeah. This article broke down object-oriented programming into 4 key concepts. And actually, in my mind, I tend to like break this down into 2 pairs, where I think of like encapsulation and abstraction as kind of similar, and then inheritance and polymorphism, I think sort of go together. And to start, I think for object-oriented programming, it's important to define what exactly is an object when we talk about object-oriented programming. And simply, I think like an object is like a combination of data, so different types of data, whether it's attributes or series data or whatever kind of data you can think of. So some combination of data and a suite of functions that apply to that you apply towards that data. So you can think of like manipulations or methods or any kind of function that you would want to involve or use on that data. Some good examples of classes that you probably use a lot in your programming is like pandas data frames, right? That's a class. That's a data structure. That's a class in Python. Other examples they give in the article is like a vehicle, right? Because a vehicle can have, different attributes. Is it a car? Is it a truck? What's the top speed? That could be an attribute. Acceleration, that could be an attribute. Color, all these things. Any sort of like abstract concept that you can break down into discrete components, data components. That's basically what abstraction means, right? Is like, taking these abstract ideas and break them down into like the essential components in terms of data and methods. And so encapsulation kind of represents that bundling together different attributes and functions. And another point they brought up when talking about encapsulation is sort of building a class. When you're the author of a class, you get to decide what components or what attributes, what data is accessible by the user and what is not, right? And you can post those kinds of limits, which is important if your object is a bank account, right? You don't want someone to just be able to like use a set method and change the bank account at will. That's not a behavior you want to allow. So you can create different restrictions like that. And when you're creating an object, and another part of that abstraction component is sort of building methods that do complicated things, but when you have it written as a method, it's easy to use. And I feel like the best way to explain that is with an example. So thinking back to like data frames, pandas data frames, you can filter a data frame, right? You can pass a condition to that function, pandas data frame dot filter, and it'll return the data frame with only the rows in which that condition is true. And that's pretty intuitive to understand, right? We know what filtering means just from our everyday, kind of language. And under the hood, the code to actually go through the data frame and check if each row meets a certain condition, move on to the next row, and to do that comparison, it's probably pretty complicated, or at least it's certainly more complicated than just data frame dot filter, right? So abstraction is another way of taking those more complicated operations that you're going to do over and over again, whether it's filter or select or whatever the case may be, taking those complex operations and abstracting them into a single method that can be used on your data type is another important part of abstraction, and super handy too, right? Because that gets into like reusability. You don't have to code up that complicated operation many times over. You just code it once, you make it a method of your data class, and then you can use that anytime you implement that data class.
Hey, you know what? Another good example is our
Yeah.
our data acquisition modules, right? Like each one of those does a bunch of stuff in the background, downloads, filters, sorts, and then returns something that's very easy to use, but we abstract a lot of junk in the background with each of those.
Right. Yeah, that's a perfect example, one that maybe folks have used before.
Yeah, I'm not super familiar with object-oriented program, but when I have built classes, that was like kind of the use case that I did build them in, was a data acquisition code. But one thing I've always kind of like, because I think it's more upfront work to build like a class, and like, so I guess I'm curious, like, when, from your perspective, when does it become worth it versus just like having some, like some functions that you call versus a class? Like, what is like the internal calculus with, like, from your perspective, I guess?
That's a great question. I feel like it ties in kind of to like the scale of your project, which is like, am I writing one script to get one set of procedures done? Like, oh, I just have this one data set, I need to fix it in this one way, kind of a one and done kind of deal, versus like, oh, this is a new project I'm starting. Maybe it's a year-long project or something. Or if you have any sense of the time scale, then I feel like, it's always hard to say before you start working, but if you have ideas about a project, like, okay, this is the project I'm going to be working on this a lot over this next few months or the next year, whatever. So there you go. You're going to have to, if you're working on your code a lot, that you're going to maintain it, you're going to update it, and you're probably going to reuse a lot of components. And all of those signs point towards an object-oriented approach as maybe being more helpful. And then if it really depends on the details of what you're doing, but if you can sort of, if the way you're thinking about your project is through like kind of this object-oriented way, you may be thinking about it as an object without even realizing it. Like, okay, here's what, like, say you're working on a watershed or a project around watersheds, and you're like, I want to do X number of operations on watersheds, and these watersheds are going to be different depending on where they are, but they're going to have a lot of things in common. Okay, well then maybe it makes sense to have a base like watershed class with all those common attributes, and then you can create subclasses based on different subtypes and that kind of thing. So I'd say if anyone else wants to jump in, I'm open to that, of course. But I would say like it's not really a great answer, but it's sort of like, it's hard to tell like hard to give a general rule other than thinking about those, thinking about your project ahead of time and sort of like having that forethought to be like, okay, is this something I'm going to work on in a long time scale? Because then it might make sense to make it object oriented. Is this something that's am I working with a common data format or common structure that points towards our object oriented programming versus say something that's purely procedural, like I need to do these 6 file manipulations or 6 data manipulations and then be done, and that's it, not have to reuse it again. But yeah, that's sort of my thoughts on it. Pat and Scott, if you want to jump in, give comments on that.
I was going to say that for me, it has a lot to do with, I think the abstraction part of this is anytime I have a group of objects that are similar, but the specifics of like how you fetch the data or how you filter the data or sort the data is a little different for each object. I like using classes because then in my my main line, my main flow, I can just say data get, data sort, data delete, whatever I need to do. And the details of what that means, what URL I go to, where I fetch the data from, how I sort it, how many columns there are, is all hidden in that class. And you don't have to care as necessarily the high-level programmer. You just say, go get me this variable I want. And there might be 10 variables or 342 variables. And if you have the methods and the interfaces written up, you just says, get this variable by name. And however it's stored, is sorted out inside that method. So it lets you have a diverse set of objects, but a sort of common method of talking to those objects for your mainline. And we've done that, oh gosh, a lot over the last 10 years or so. We one of the first things we did was in our big integrated model, we said, let's create this thing called a bay. And in that bay, there are many things like what rivers, feed that bay. Where is it? Are there buoys associated with it? Are there any, key locations associated with it? And all of those are in the bay. And you just say, hey, bay, hey, bay, give me your climate data. And out it comes. And how where that came from and exactly how it was stored is sort of buried inside the bay class. So we've done that a lot. The other time I find it's really useful cognitively is if the things that you're talking about really are physical objects. Sensors are great for having object classes. I do some low-level electronics microcontroller sort of work, and having a callable entity or an object that you say, go initialize this card, and the card knows how to do it. And if it's an audio card, play this thing, pause this thing. You don't have to worry about the details under the covers that it's a serial port and I've got to send this string to the card and the card's going to react. You just say card, card.play, card.pause. It just in my head, it helps me visualize that it's a physical object. So those are the sort of two times I lean heavily on classes and objects in my coding.
Yeah, I'll say something quick before, if you don't mind. Shari, is this on the current topic, or are you going to switch it?
Oh, I was just gonna say that I kind of tend to think of it in terms of I lean towards object-oriented programming if I'm developing a product that's going to be handed off to someone else, like a stakeholder or client. I feel like Noah and Scott already made the points of maintainability, scales, but in general, if you're trying to build a product for someone else, they don't have to worry about the nitty-gritty. So encapsulation and abstraction kind of pop in over there, where they can still use the product without having to worry about all the intricate things going on in the background. And if it's something that we're going to maintain for the client or stakeholder for a long time, then regular updates to the class and all of that would not affect their workflow. So it's kind of good for long-term projects like Noah mentioned, and also like Sal was mentioning, abstraction and encapsulation is huge because people don't like seeing a whole bunch of details on their page if that's not something they need to be concerned with. So for example, the model that I'm building will eventually be handed off to NYCDP. So I'll be converting that into a class object-oriented infrastructure as well. So they only need to see what they need to see without having to worry about sorting through the code or figure out what's going wrong.
Yeah, I have two things to add. So the first is I'm going to push back a little bit, Harrison, on it's harder to write object-oriented code or it's not as easy. I think it's just the workflow you get accustomed to. And the reason I say that is because for years, every bit of code I wrote was object-oriented because it was in Java. And Java forces you to write object-oriented code, right? The main function, the main class sits in a class, and then you run out of main, and then everything you call is either in a different class or in that main class if you're writing, like uh, I'll say garbage code. You really don't want everything in the main class, but people do it anyways, right? And that becomes more functional. But like that's object-oriented code. And so like I don't think it's harder. I think it's just like when you start out, instead of writing a big long script, put that main function in a class to start. It's 3 extra lines of code. And then you have your main function there. And then when you want to like do other things, make another class for that other method or that other data. And you can even do it in Jupyter. You can think of your main function being in like one cell, and then you can use the other cells to build out your classes. And then once if you want to modify a class, you just go back up, modify that cell, rerun that cell to redefine that class, and then you're off and running. So I don't think it's necessarily harder. I think it's just getting used to that workflow versus like how we're taught to think of things as human beings in a step-by-step functional way. So yeah, and so that was kind of my first comment. I don't think it's harder. I think it's just a habit more than anything else. The second thing is, I don't really, so I have not, I guess we have written a couple of classes lately, but we don't write a lot of classes in the code that we put together for you guys. But we do use abstraction, we use polymorphism, we use all these concepts in our code. And so even though we might not have a class statement, we like divide things up into different files to abstract them and keep them separate. That whole the data acquisition set of modules, there is no class statements in any of those. Like we should do it, and one day we probably will. But right now it's just different files, and then we use polymorphism on the get data function, and we just define in all of them. So you don't need to use the specific object-oriented structures to do object-oriented concepts in programming. And so because I was trained in object-oriented programming, like a lot of stuff I design and think about is very much in terms of encapsulation, abstraction, polymorphism. But do I use those actual programming constructs all the time? Not since I've been freed from Java, not really.
Yeah, that's a great point, Pat, about using abstraction and polymorphism and these characteristics without necessarily creating a class per se. You can definitely still have those things, and they're good practices to have because they will make your life easier, even if you're not going all the way and making a class per se. How is that sufficiently answer your question, Harrison, or at least get some gears turning?
All good points. And I feel like, Pat, to your last point, like I think I do use object-oriented programming concepts in the same way that you just described, but I'm just not always I'm honestly rarely defining a class.
Yeah.
And like one other thing that comes to mind, or I guess the question that's kind of a follow-up is, so like when you're starting like a new project or something, in terms of file structure and like you have all your, do you prefer to kind of store all your helper functions in like one, like a main class, like you were saying, or do you like to kind of have a more like parsimonious file structure? Yeah, I'm just curious how other people like to structure their projects when they're starting.
Well, one thing that we try to do that we don't always do, I know what Scott's going to say, is, I have a fire alarm going off. So I should probably switch. Scott, you talk and I'll switch to my phone.
Oh, you're muted, Scott.
Got muted.
All right, unmuted. What I was going to say was that there's obviously a balance there. First blush, yes, I group a bunch of related classes, functions, utilities into like a shared file, a side file, especially if it's something that I'm going to be, calling from multiple other scripts. I try to get away from the one superscript that's got 37 functions defined at the top and a main loop at the bottom, and pull that stuff out. Some of that's for maintainability, especially when you're doing team programming, and it helps Git, because Git's pretty much file-based tracking. So the more files you have, the finer granularity you have of having somebody work on this piece of code without stepping on your piece of code that might be in the same file. If they're in separate files, it's really simple for Git to merge things because it's just file by file. You either take the file or don't. If you have multiple people editing the same file because there's 10,000 lines of code in it, then it ends up getting dirtier for just merging updates from multiple people. So that's part of what drives me to do it. And the other thing, sometimes a class becomes such a keystone that it needs to be to itself. For the same reason, if I end up throwing lots of utilities into the same file, eventually that file gets so much stuff with potentially so many authors that need to touch it that I want to split that file, which it's easy enough to do. You just do another import, right? Import. Nice thing with Python, at least, you can say, it doesn't have to be an actual library. You can just say import this .py file. It could be / utilities.py. So I'm in, I'll go up one directory and go to where I put all my shared files. And we've done that with our integrated models as well. We have like a directory for each model, each module wrapper, or each piece of the workflow wrapper. But there's some shared utilities that are like typically one directory up that's shared by a whole bunch of, all your modules use these same shared utilities. So we split it that way architecturally, file-wise, just to have not as much duplicate code. The little personal project I most recently worked on, I started that way, but then I found, that we found the exception that broke the rule. I'm going to make a copy of that function and have this one time for this release be a unique instantiation of that function, within this module. It may have the same name, but it's called by that module because it something broke the rules and we couldn't make it a universal called by all module. So I've done that as well. Usually I try to mark those as short term and try to get that duplication of code gone and merge all of the behavior for that same named function into the same source code eventually. So there's obviously there's a fine line. There's no one answer. And for the the expediency of getting something released and running, sometimes you sort of, I won't say dirty code, but you cloud the waters a little bit. You're not quite as pure in your architecture as you'd like to be, and maybe you put a little bookmark on that to say come back and clean it up. So that's my take.
Yeah, to reiterate what Scott said, I'd say it's super common and useful to have one Python file or whatever language, but have one file of the functions that you most commonly use, and then you can just have that be like, I usually call it like utils or utilities.py or library.py are common names in a project to name like kind of a file that has all these functions that you have found yourself using over and over again. It's a good place to store them. But that's actually a good point. Did people know that you can do that in Python? Like you can dump all your functions into a file and then import it in other files like it's a module, like it's pandas or numpy. I feel like that's a really helpful tip that I personally didn't know until
you don't have to source it.
Someone told me.
Just put it in import at the top of the file like any other lib.
People know how to do that, or is this like news? difficult?
I learned how to do it. Have I done it a whole lot? Probably not. Just because the scale of the projects haven't gotten to that point yet, and the amount of code reusability is not there. But I can imagine how it'd be super helpful to just pull these helper functions from utility modules or just separate classes stored in a file. Because you don't have to keep coding up classes over and over again, and you can
avoid copying and pasting functions
into
your notebook or script or whatever.
I don't want to have multiple copies of the same code laying around. I mean, if it's because every time you need to update that, say, oh, I did a thing and I wish it was better. I want to add a feature. You got to add that same feature to like 10 copies. It's like, well, that was a bad way to go.
Yeah, totally. I feel like, generally speaking, there's a fine balance between encapsulation and modularity. So in the case of, I guess, throwing all these helper functions into a single class, it can help with not having to worry about a helper function not being able to access methods or having to use other means of accessing methods. But like you mentioned, Scott, it makes the class bloated almost, for lack of a better word. It's hard to read the code, and it's just so humongous. You're just scrolling through the entire class to find stuff. So it increases code complexity, and it's hard to read it. Whereas just making separate classes improves organization. Obviously, you can copy and paste into a separate file if you need to. Like Noah was mentioning, just put them all into a single file, and then you can use them or import them whenever you'd like. And overall, for me, it's just about code readability, because I find that I get lost in my own code sometimes. So I just try and make it as structured as possible for myself, because we can always copy and paste them into a single class later on if needed. But beginning with distributed and easy to read code is my way to go, because I frequently get lost in my own files.
On the something else about classes that I have made use of, and I find good, is sort of data hiding or data encapsulation. Again, is guess what it is. There are some variables that are associated with an object that you want the users of that object to have access to. So you define those as instance variables. And you can say object.thing, object.attribute. What is it? Either set it or read it, or make conditionals against it. But in that class, there can be internal variables that the users of that object never see, but you want to have persist between. It's an internal variable of that object. That instantiation of that object might be the state variable. If you have a state machine or some such thing. So you can have information that only the object methods see or know about, and they can pass things along between themselves. You'll see often there'll be this concept of self. So you have this self dot this or self dot that, which is it's one of my attributes. Self dot value, self dot variable, whatever it might be, self dot speed, self dot color. And by having a lot of that noise sort of not in your user's data space, you don't have to see all those internal variables. I just think it helps make the user's job, the user of that class, easier. They don't have to necessarily know all the details of how you're implementing the initialization function, but it's in there. Like what the default values are, and how do you clean up something? How do you delete an object or add to a list, or add, concatenate two objects or copy an object? Just another way of something else I do with classes. This idea of variables that are exposed to the user of the object and variables that are sort of buried inside the object. You can split those.
Pat's ready. Do you have something to add?
Yes. So on the topic of that, like putting everything in one big file, like you guys know that we do that a lot. but I feel like we always make a big mistake of putting everything in one massive file. And then when we want to make a change, we always have a problem with Git, right? Because someone makes a change in the top and someone makes another one in the bottom, and then we're changing the same file. And Git usually does a pretty good job with that, but like every once in a while, it gets all angry. So going back to Sharya's point, I do feel like there is a balance between like making it super easy to use by just having one import statement, and then like crowding a file with like too much junk that makes it hard to see. I think the right answer that I'm poor at making us do and implement is keeping those like utilities files a reasonable size, and then having like a master import file so that if you want to like use everything, all that file contains is like import the 15 other files. And that way you create this like layered approach where you have, a lot of stuff that you can import with one easy statement. And then that just calls another file that imports the 15 other ones that keeps it all separate and nice and tidy. I think that's probably the right way to do it. But yeah, I don't know. I don't think there's a really good answer for this. There's definitely a trade-off there.
Well, I like that idea, Pat, because it leads into this, it ties in with the concept of inheritance, which is another one of the key components of classes. And that's sort of the idea you're talking about, where you have maybe one base class or, one, maybe the way to think of it would be like, one master import that imports all these things. But then you also have these subclasses, or in parallel, you might have these smaller files that you import for. You might just import this one file for a specific use case, another one for another. But if you want all of them, there's a generic import that will get all of those kind of sub imports. And when we're talking about classes, that's basically what inheritance means, right? You have one generic class. Say, I think the example they used in an article, which I liked, was vehicle. Like, say you have a vehicle class, it can be car, truck, motorcycle, whatever. Vehicle would be the base class with some generic attributes and methods that all vehicles share. And then you could have subclasses like motorcycle, car, truck, that have different, other unique attributes that are different between the three of them. But they all might inherit this common method called drive, right? Because that's one behavior or one method that applies to all of them that they inherit from the base class. So that's the idea of inheritance. And I think what Pat was saying is actually a great idea of that concept of inheritance outside the specific application of the classes, right? It's like we'll have like specific, we'll group our utility functions or helper functions in specific categories that make sense, right? Kind of subcategories. But then we'll have like one generic base import statement that imports all of them, analogous to like, say, your base class. And then it seems like some people kind of already have an understanding of these terms, but just in case people didn't, I just want to touch on polymorphism, which is the last key component of object-oriented programming. And we've talked about that already. So basically, to summarize what that is you can have different objects, but the same sort of method, and the method does different things. And that's like a perfect example that Pat mentioned, are get data, attributes. Different data sets, but our get data function is the same, right? Same arguments for the most part. Same function signature. Although under the hood, completely different, but that's like hidden from the user. Another common example would be like a data frame, Pandas data frame versus a series, right? A lot of times, there are methods that are shared between the two, maybe whether it's filter or get or select, whatever. So you as the user will use those same methods. What's done under the hood probably different. So I just wanted to clarify in case it seems like most people had already had a grasp on what terms mean, but just in case others were unsure, I wanted to just touch on those real quick. And then, yeah, maybe thinking about some of those prompts I send the email. We've already had touched on some of those in our conversation organically. Sort of the trade-offs and when to use. Harrison had, was asking some great questions about when to use object-oriented programming, how to know when to use it, trade-offs between it. I feel like maybe a good topic for discussion kind of related to that is, why might object-oriented programming be useful to think about and understand, even if you're not building your own custom classes? Because I don't want to say that's more work, but it may not be applicable in all cases, right? A lot of times, whatever your task or program may be working on, maybe it's a gray area, maybe it's not exactly procedural, but it doesn't exactly make sense to put it all in a class, so it's somewhere in the middle. So thinking about how can I apply these principles even if I'm not going all the way and using and building my own class. But think about incorporating things like inheritance or abstraction, even if you don't have a class, I think could really serve you down the line. And then even if you're not, building, even if you're not even using these principles, understanding inheritance and polymorphism often comes in handy if you're using other modules, right? If you're using, I work a lot with datetime, the Python datetime objects, and there's date times, there's time deltas, there's date objects, and I kind of, because they're all related modules, are all related objects, and subclasses of the same base datetime object, I know that they're going to share a lot of the same methods, or there's a good chance they will at least. So, if I do one method on a datetime object, I don't really need to go check with the docs and Google to make sure that it works on dates. I can kind of just assume or guess that it does. It makes sense. If there's a function to format a date a certain way, probably going to work on a datetime as well. And the reason I know that is because I'm okay, well, this is a class, probably going to be inheritance here, where the same method applies to the same different subtypes of objects. So that just having that concept in the back of your mind, I feel like saves you some time, saves you some Googling, or saves you some having to check of, okay, got to be sure this method does the same thing on this similar but different object. Yeah, Scott.
I was going to say another, almost a cheat, or a non not as Pythonic as some code should be. I find myself often wondering or wanting to have some sort of a global variable, which Python does not really, it frowns on global variables, but it's quite fine to have a global object. So I will often have in a structure where there will be like that Bay object we spoke about. We'll have this object that's shared between a bunch of code. And in that object are the values that I want to have shared. Another way to communicate between functions or between procedures is to pass this object around. So the Bay object, and I just wrote some code for some stage lighting control. I created a scene object, and in that scene object, it had attributes of the scene, whether the scene was paused, whether the scene, what was the elapsed time in the scene. All of that was kind of buried in the object. I just passed that object around. So, and then any piece of code that needed to know something about the scene could just say, hey, scene, what you got? And it's like a global variable, but it's a cleaner way to pass it around. So like I say, it's kind of a cheat. It's better than just putting a big variable at the top of your code and hoping that all the sub-functions have access to it. That works great until you move your function to a different file. and then it's kind of not in your scope anymore. That variable that you left behind in the other file isn't available to you anymore. But if you're passing this object around, this scene object or bay object or environment object, I find that's a sort of a good way to have like my operating environment as an object itself.
Yeah, that's an interesting point, Scott. So anyone that does .NET programming, I don't think anyone here does that, but they have a kind of like the standard structure for .NET applications is to start with an application object. You like inherit from the application object. And that application object is kind of where you put all your global variables. And Java kind of works in the same way, right? Like you have your base class, you can definitely define global-ish variables in there. And then if you call something that needs it, you can pass that like one variable, but everything in your main has those global variables fitting in there. It's kind of the same concept of this application class. So yeah, Scott's way is great too. You have like a settings object or like a overarching object that contains all the data that you need for your kind of your code and pass that around. Or you can kind of do it in this way of like hierarchically where you have this application or overarching main class and you can define your global variables up there and then kind of pass it around as you call and manipulate the other objects.
Yeah, if nothing else, it keeps the parameter lists short.
Yeah.
If I know I needed like 6 things from this, environment for that function, I don't have to pass 6 things. I just pass my environment object. And, that's the function that needs it, fish for the 6 things it needs.
Yeah, I think sorry, go ahead, Shoria.
Oh, I was just going to say that I was taking some notes while I was reading this article. And based on this question of why AOP understanding might be good, the first thing that popped into my mind was, and Donna lives and dies by this as well, is modifying existing black box models. Like there are so many people who just import libraries and run these models as is without obviously knowing what's going on under the hood. So even when they're writing out their research papers, also computer science papers don't really delve into the complexities of, oh, this is the exact nuances that we handled while hyperparameter tuning our model, or these are the exact number of units we used, or discuss specifics. They'd just be like, this is something generic, like we hyperparameter tuned the model, and it's like a 20-page paper with one line of explanation of what they did to fine tune their model. So really having OOP background is good for, I don't know, extending the functionalities of existing Python libraries and even frameworks like TensorFlow, PyTorch, all of that. You can just take existing code that other people have used and kind of use almost transfer learning and make it your own, or try and make it more specific to your domain, your data set, your problem. Lots of these black box methods, models, algorithms kind of do use OOP encapsulation under the hood. So once you like pop the hood off, you can make it your own quite easily. But I feel like people are so scared of opening that hood, opening that box of worms, right? Everybody just finds it convenient to just import the library and just pass in the built-in parameters, pass in values, and see how that performs on their data without really exploring the nitty-gritty and getting your hands dirty of what's possible by going under the hood.
Yeah, that's a great point, Shoria. Thinking about, using these concepts outside of the realm of your own classes. It's important to know, like, this as a programmer, like it's good to have a good framework to have in your mind when you're working through things. Maybe we can turn it to a little bit more personal. Like, have people used object-oriented programming before in your work? And maybe if you have, if you don't mind, like sharing your experience with that. Like, what did you struggle with? Why did you decide to go with an object-oriented approach? Or maybe you didn't. Why didn't you decide? Did you use any of the principles of object-oriented programming without necessarily building your own class. Or if you haven't implemented OOP programming in your work before, how might you? Like, do you think, would it be helpful for any of the projects you're working on? Would any of these principles be useful? Yeah, sort of thinking about how this could apply to our own work. Wondering if anyone has any comments to share on that. Insights may be gleaned from this article or discussion today.
You've already said enough. I've already used multiple examples of where we've done this over the last.
Yeah.
I was here when they defined what the term meant. So when C became C++, you know. So yeah, I've kind of seen this take hold. It's definitely a valuable programming structure.
I think about it a lot. A lot of times in my work, it's almost like retrospective. It's like almost like I'm working on something. A lot of times, working on data sets for our lake model, and we kind of split those data sets up into periods, like a spin up period and a forecast period. And a lot of times I find myself thinking like, man, this would be a great object class to have because there's so much in common. But it's almost like, you realize that in retrospective, but it's still, like you don't have to necessarily go back and rewrite. Like having that thought, like I'm like, part of me wants to like, oh, I should go back and rewrite all this code, but that would be a lot of work and a lot of time, and maybe not the most efficient solution. Whereas thinking, okay, well, if I'm not going to rewrite all this code, and refactor and all that, I can at least use some of these principles, like polymorphism through get datas and similar functions, to get closer to an object-oriented approach, even though it may not necessarily be a class that I've designed and implemented. Getting closer and using some of these principles in your work, you'll still get some of the benefits of object-oriented programming in the sense that it'll be easier to maintain, it'll be more readable. So you still might get some of the benefits even without having to necessarily retrospectively refactor your entire project. Yeah, sure, yeah.
I was going to say, I don't have a specific use case, but I feel like some people may be using more object-oriented programming in Python than they imagine. Like people who are familiar with PyTorch. PyTorch is pretty similar to OOP principles. It's based off of the structure of classes and objects and methods. So if you're using PyTorch, you're already kind of halfway there. And you're already using principles like inheritance, abstraction, polymorphism, because you can create subclasses under the torch and then modules. There's so many things with PyTorch that can really, it's an easy way to convert your code workflow into a completely object-oriented setup. And also, I think it's great for reusability. Some of these things some of the models that I've built over however long I've been here, I find that the PyTorch implementations of the same models is far easier to debug, troubleshoot, and modify compared to their TensorFlow equivalents. Also, it just feels like PyTorch has more people giving input and updating classes for some reason, which obviously the class structure of it kind of makes it easier to keep making updates and keep making small revisions. And overall, just it's user friendlier. I feel like there's less syntactical need for, I guess that could be argued on, but I feel like it's there's more standard syntax, so a lot more people can contribute and modify existing libraries or code written in PyTorch as well.
Yeah, I just wanted to share my experience a little bit. So I learned coding from my graduate advisor for the most part, who was an old school coding in C, throw everything in a single script, copy functions across scripts from different projects. And yeah, it gets really confusing quickly, and things that you thought you updated, well, then you ended up going and pulling it back from the wrong file, and now it's not updated anymore. And so I learned Python and class usages in a USGS internship a little while ago, and it's really so much better, like so much cleaner and more organized. And we use things like property methods to protect variables so that they don't get set incorrectly. And yeah, I just want to plug in. Like I'm fully on board, and it's definitely the better, cleaner way to go, especially on collaborative projects.
Say Java was much more rigorous in its enforcement of the set and reset. Sort of, you need to call a method to change a value. Versus I'm kind of a middle of the road for Python. It's like, yeah, I've got the object, but I'm just going to touch the object with a variable equal something assignment. But you're right. Using those set methods gives you so much control. It says you don't have the authority to change this variable. You're not allowed.
Or this is supposed to be a float, and you're trying to make it an integer.
Yeah. What are you doing?
Mm-hmm.
Yeah, I just want to say that I freaking love polymorphism, and Scott's probably rolling his eyes, but I love to use it all the time, and it's kind of my secret trick. And oftentimes when I'm designing code, I often think of how can I make these functions general so that it doesn't care what kind of thing I pass it or what style of climate object I pass it. It'll just do the job. And that's why I like Python a lot, because the community loves these object-oriented concepts, and polymorphism is right throughout Python. Like I keep finding things that people keep implementing across classes that I didn't know are there. Like most data structures in Python, regardless of what library you pull them from, have a plot function. Like you can take a data structure and put .plot. And almost everything in Python has some plotting function to show you what it is. And it understands whether it's 1D, 2D, 3D. It has like histogram if it's more histogram data. Like it's kind of one of those hidden secrets in Python that like everyone implements the plot function. And there's like a couple other ones like that too, I feel like, that it's just the Python community does a really good job with polymorphism. Like there's certain things you can do with a ton of different objects, and you can kind of forget, like, do I have a pandas data table? Do I have an Adobe Air data table? Like it doesn't care. You just call the same code, the same functions, and polymorphism takes over and does all that work for you. And that's one reason why I really love Python, because of that polymorphism aspect to it. It's super powerful.
And that's I think a great principle to keep in mind when you're writing your own functions. Maybe you're writing a function with a specific use case in mind, right? Like doing a series, maybe, a lot of times I do this with like data manipulations, like messing with the index, like of a time series. And usually you're doing that with a specific use case in mind, whatever you're working on. But challenging yourself to think, okay, well, what if the index was slightly different? Like, what if it had a different time frequency? Instead of every 15 minutes, what if it was the data was at a different frequency, like hourly or every day or something like that? Would my function still work? Or what if instead of like a series, it was like a data frame? Would it still work or would it not? And like sometimes, depending on what exactly you're doing, you might realize, oh, actually, if I tweak the way I wrote this function a little bit, now it can work with series or data frames, or now it can work with different types of indices, or whatever your function may be working with. Thinking about, oh, could this apply to other data types? That is polymorphism, right? You're designing your function with like, okay, I want this function to be robust. I want it to work with similar but different data types, right, or different data structures.
Then,
that's
then
like,
maybe more
you know,
our mindset, though. I mean, for those of us who are in the business of creating libraries or creating reusable code that multiple teams, multiple researchers can make use of, I'm not. For folks who are racing for the finish line to get this paper written and they need some data analysis done,
yeah,
maybe all of this is extra.
that is true.
But it's good to keep in mind. I mean,
Yeah, so
Yeah.
so no, I will say what you described is technically like backwards polymorphism, right?
Right,
So,
yeah,
but
yeah.
I think the concept is important, and I think it's, for me, it's borrowed from that, right? Like polymorphism
Mhm.
is technically like you have different objects, you call the same function on them, and they do something different, or for that
Yeah.
object. The code
For
that
the
we
object,
normally
right,
write
yeah.
kind of, we make the functions flexible to take in
The
different
inputs are
objects.
more, yeah.
And
Yeah.
and so the inputs are kind of polymorphed, but
Right.
I do want to agree that the concept is very, very similar, and it's kind of just
Yeah,
polymorphism from
you're
the
right.
other direction.
Right. It's not strictly polymorphism in the sense like like you're not working with classes per se,
Right.
or like a method of a class, but you are thinking about how can I make this apply to different inputs, different data
Exactly.
structures.
Exactly.
Um,
And so it's like what we talked about with Harrison's question. It's applying
Yeah.
object-oriented concepts to non-object-oriented code.
Totally. Yeah.
Yeah, there's certainly a
Um,
level of buy-in, a level of commitment to the craft. You can dabble with a very simple class or two, and a couple of methods, or you can reduce work your code to the point where there's like not a function left in your main call. It's just object, object, object. There's a whole continuum. I'm definitely more on the procedural side with a few classes sprinkled in as sort of my comfort spot. But I like to use other people's classes. There's a lot of really good libraries out there.
Well, this has been a great conversation, and we're at our time, and it's nice to have the conversation roll into the next hour. I think that's a good sign. Hopefully you found this helpful. Does anybody have any off the top of their head quick suggestions for next week or any ideas? Afterthoughts? Otherwise our team will come up with an idea amongst ourselves. And
Yeah.
All right. Well, we'll come up with something, and we'll see you guys in 2 weeks.
2 weeks from now is Thanksgiving week. I don't know who's doing what on a Tuesday morning.
Oh,
but
that's true. Actually, I think
maybe we'll be here. It's not a holiday, I don't think, but
not a holiday for staff.
not a holiday for those of us pulling paychecks.
We will consult and decide whether we're going to do that.
We
but
will.
I-
We may
I-
do a.
I
So
think we
maybe
might.
see you all
We'll
in 2
see.
weeks.
Yeah.
So, yeah, thank you all.
Yeah.
Right.
Thanks for the conversation, folks.
Thanks all.
Bye.
Bye.
Stop.